Hello, everyone, and welcome to today's webinar, Algal Blooms and the Impact that Phosphorus has on our health of our lakes. Just so everyone knows, today's session is going to be recorded and a version will be made available within a few days through our website and on our YouTube. Your microphones and cameras have been turned off on our end, so we cannot see or hear you, so don't worry about that. And we are going to begin today with our Environment Program Coordinator, Cassidy Mazer, who is going to be giving a land acknowledgement. Cassidy?
Okay, thanks, Bree. And I know we're all in a virtual setting, so a land acknowledgement looks a little bit different than if we were together in person, but I hope that wherever everybody is joining from today, we can all take some time to reflect on the traditional land that you're on and the Indigenous nations who have been and continue to be stewards there. And I'd like to acknowledge that our activities in the Lake of the Woods District and the research being conducted at IISD-Experimental Lakes Area are all located mostly in Treaty 3 territory, which is the traditional territory of the Anishinaabe Nation. And today, as our topic focuses on fresh water, it's important to remember that the beautiful lakes and shorelines and resources in this area that we all use and enjoy are all culturally significant to the Anishinaabe Nation, the Métis Nation, and many other Indigenous nations. Treaty number 3 is home to 28 different Anishinaabe nations and who have all been stewards of this land since time immemorial and fulfilling sacred relationships and responsibilities. And LOWDSA and our LakeSmart team, we hope to honor that through our own relationships with the land and the water and fish and wildlife and other aspects that are all culturally significant to Indigenous nations through our actions, but also largely through our mission, which for LOWDSA is to preserve one of the most beautiful places on earth as a high quality environment for future generations to enjoy. So today, as we're focusing on algal blooms and nutrients in our lakes, and as you think of your own actions that impact that, I hope that we can all reflect on the longstanding stewardship of this land by Indigenous people. Thanks, Bree.
Awesome, thank you. My name is Bree McCardle. I'm an environmental stewardship technician for Lake of the Woods District Stewardship Association, also known as LOWDSA. The LakeSmart team is an environmental outreach and education program, which is unique to our area. It is made up of post-secondary students who all have an environmental focus. And we are super excited this year to get out and spread information on invasive species, septics, healthy shorelines, and pretty much anything that's going to help people to live and play green at the lake. Also, just so everyone knows, the Q&A function, we welcome and invite everyone to put in questions, comments, and we will be addressing them, at the end during the question period. And you can also, if you prefer to ask the questions verbally, you can use the raise hand function and we will unmute you, and then you can ask your questions also at the end. So today, normally we get to do site tours at the Experimental Lakes Area, but until we can get back to in-person activities, we get to spend time with our neighbors virtually. So we have teamed up with IISD-Experimental Lakes Area and Dr. Mike Patterson, who will be giving the presentation today. So Dr. Michael Patterson is the Senior Research Scientist at the IISD-Experimental Lakes Area. The IISD-ELA is a research facility in the Northwestern Ontario that uses whole ecosystem research and experimentation to better understand and find solutions for problems affecting freshwater. Mike has worked at the Experimental Lakes Area for 30 years and has led or participated in multiple research studies on a variety of topics, including algal blooms, contaminants, climate change, and the effects of hydroelectric reservoir development. He is on the Technical Advisory Committee for the Multi-Agency Arrangement for Lake of the Woods and is an adjunct professor at the universities of Manitoba, Trent, and Lakewood, and Winnipeg as well. So we are very fortunate to be hearing from him, and I myself am super excited to learn and listen with everyone today. So we are going to begin with some polls to get everyone ready to go for the presentation. And then Mike, whenever you're ready, you're good to go.
Okay, so our first poll here is just on how much you know about phosphorus and its impact on fresh water. So we can see how much background everybody's got. And I'll give some time for everybody to get their votes in. Okay, I'll give a couple more seconds. All right, so I'll share those with everybody just so everybody knows where everyone's coming from. Awesome, and then I have another question here on how everybody heard about our webinar today. I'm curious where you're coming from. And this one you can choose more than one answer too. So if you saw it in a couple places, feel free to say that. Okay, and I'll give it a couple more seconds here. And again, fun to see how everybody is hearing about our event today. And our last one before I pass off to Mike here is another background question on how much you know about IISD-ELA and their research. Okay, a couple more seconds. And I'll share that one again there. Pretty good rounded out results. Okay, thanks everybody. And I will pass it off to you, Mike.
Hey, thanks. I want to thank LOWDSA and LakeSmart very much for inviting me to give this presentation today. Just as a quick question, how do I remove the poll? Oh, I just minimized. All right. It's really great to have an opportunity to talk about algal blooms and the research that we're doing at the Experimental Lakes Area on that. Perhaps if I'd seen the results of the poll earlier, I might have a slightly different presentation. For those of you that said that you had a lot of knowledge about eutrophication, you'll probably be disappointed because this is a very basic introduction to eutrophication. What are the causes of eutrophication, why it matters, and what are some potential solutions. And I hope to finish up by talking a little bit about Lake of the Woods, since I've assumed that that's the water body that most of the people that are on this webinar are interested in. All right, so there we go. So what I'm talking about today is a process called eutrophication, and it's really just a scientific term to describe the condition of lakes and rivers that have dense blooms of algae or phytoplankton. And I'm sure everybody on this call is familiar with this problem. I don't think you would get much argument from any limnologist anywhere if I said this was the #1 water quality issue in the world. There are millions of lakes and rivers around the world that are affected by eutrophication, and many of the lakes that all of you know well. Lake of the Woods has problems with eutrophication, like Winnipeg, like Erie. And then countless other smaller lakes, ponds, and so forth are affected by eutrophication. And eutrophication is a problem that has been the focus of intense research for decades. And over the decades, we have learned a lot about what the causes of eutrophication are and how to deal with it. But there's still a lot of questions that remain. And I have to say that globally, we're still struggling with this problem. So to get to the very beginning, I just wanted to talk about what are algae, what are phytoplankton. And they're really just simply microscopic plants that float in the water column. And if you look under a microscope, like the pictures on this slide. They have an enormous diversity of different shapes and forms, and it's not at all unusual to find 40, 50 species in any lake at any given time. And while I'm here today to talk about harmful algal blooms and eutrophication, I do want to emphasize that phytoplankton and algae are essential for all life in water, and they form the base of the aquatic food web. They're fed upon by small invertebrates and insects, which in turn are fed upon by fish. They're responsible for generating all of the oxygen that we now breathe over the past millennia. They're also important for sequestering carbon, mostly in the oceans and marine systems. So phytoplankton are not bad. They're essential. They're crucial. It's only when their densities become excessive and lakes and rivers become green, like some of the pictures I showed you in the previous slide, that they become a problem. And there are a few taxa, species, or kinds of algae that are especially problematic because they can become toxic or cause surface scums and things like that that are highly undesirable. And in particular, there's a group known as blue-green algae or cyanophytes that are considered to be particularly problematic. So because phytoplankton and algae are just plants, they have all the same requirements as the grass in your lawn or the trees in the forest. They need light and they need nutrients to grow. And nutrients are really just the essential elements and building blocks that organisms need to make their bodies. And the ones that we talk about most for algae and phytoplankton are carbon, nitrogen, and phosphorus, but there are many, many other elements that are also important for the growth of algae. And if they don't have them, they won't grow. And eutrophication is generally the result of excessive amounts of nutrients that are added to lakes or rivers that cause the algae to grow to these really high levels that become a problem. And of course, there are natural sources of nutrients, or else we wouldn't have phytoplankton to support fish and all these insects and other things. But it's also been known for 100 years or more that there's many activities that we as humans do that contribute nutrients to lakes and can be responsible for causing eutrophication. And while eutrophication can occur naturally, most frequently it's related to human activities. And that's something that we call cultural eutrophication, or the over-fertilization of water bodies with nutrients from human activities, our activities. So where do nutrients come from naturally? It's important to just recognize that lakes and rivers are really just low points in the landscape that collect water. And rain falls on the land, it flows over the land and through the soils. And while it does so, it picks up nutrients and other things that are on and in the soils and carries them into the lakes and rivers. And plants that are growing on the land, they're using nutrients that have originally come from erosion and things like that to build their bodies. And as they die, they decompose and form soils, and they contribute to the nutrients that flow into lakes. And typically, if you go to areas that have very thin soils, like the Canadian Shield or mountain areas, the lakes are very clear because they have very little growth of algae in them. And as you move to areas that have thicker soils, more developed soils, you often find there's more nutrients getting into lakes, and they tend to be more productive. So while these are the natural sources that are crucial for supporting lower levels of phytoplankton usually, I want to spend the rest of my talk talking about human sources of nutrients. And we have a series of polls throughout my talk. And the first one is here, and I just wanted to ask your opinion about what you think are the most important human sources of nutrients to lakes. And you can select more than one of these. All right. Oh, there's still some answers coming in.
I'll give everybody a 5-second countdown.
Okay.
Okay, it looks like it's slowing down. I'll end it and share that with everybody.
Yeah, and it's clear that most people on this webinar are familiar with the most common sources of nutrients to freshwaters. They're sewage treatment plants, fertilizer from agriculture or lawns and things like that, feedlots, many detergents, and storm drains are all important sources of nutrients to lakes. Fossil fuels less so, although they do generate nitrogen. And I'm going to talk more about nitrogen later, which may contribute to some issues. And pharmaceutical products, by and large, are not a major source of nutrients by humans to lakes. Oops. All right. So as I mentioned, many of our activities, these things like fertilizers and sewage treatment plants, septic fields, and so forth, can potentially contribute nutrients to lakes and to rivers. And we typically distinguish between point sources and diffuse sources of inputs. Point sources are localized inputs, usually from a pipe or something like that, from things like sewage treatment plants, or industrial plants, whereas diffuse sources are more general sources of nutrients from runoff on the landscape and things like that. And by and large, we're fairly good at dealing with point source inputs, and there are a lot of methods for removing nutrients from point source inputs if we're willing to spend the money. Those kinds of inputs to lakes have been dealt with more easily than the diffuse inputs, which are really problematic and often require large-scale changes in our behavior and in our activities. And this slide just sort of shows some of these inputs. I also want to just point out that nutrients that have been introduced to lakes in the past they're taken up by the algae and then they sink to the bottom and then they become incorporated in the mud and the sediment. And these nutrients can become available again and again and again over time and be reused or recycled. And this can become a real problem when it comes to the recovery of lakes from eutrophication, because you not only have to wait for the nutrients that are being added to be gone from the system, but you have to deal with these recycled nutrients. And I'll come back to this later a little more when we talk about Lake of the Woods. So eutrophication is a very undesirable state for a lake to be in for a lot of reasons, especially when it comes to our uses of lakes and rivers. And one of the most widely cited problems that's related to eutrophic lakes and rivers is that associated with toxic algae. And there are certain forms of algae that tend to become more abundant in eutrophic systems, and some of these can create toxins. And this can cause liver failure, it can kill organisms in the most extreme cases. It can cause skin rashes, things like that. So this is obviously something you really don't want, and it will lead to beach closures. The city of Toledo, which is a city not that much smaller than Winnipeg, had its water supply shut down for several days a few years ago because of toxic algae that was in the water and presented a hazard. Having said all that, these kinds of levels of toxic algae are very rare, and it's not something that we encounter very frequently. More frequently, high levels of algae in eutrophic systems can cause taste problems in drinking water, which people don't like. And there's no question that high levels of algae degrade lakes for recreational use, and people don't like to swim and be in lakes that are green and goopy. And I think there was a study I saw a few years ago that showed that the price of cottage land is very highly correlated with how clear water is. People don't like to buy cottages on green lakes particularly. And eutrophication is often associated with other water quality problems, such as bacterial issues and like E. coli. And perhaps, the last reason that we should be concerned about eutrophication is that in many cases we treat the water to avoid some of these nutrient problems. But water treatment is very, very expensive. And we're, I don't know the exact number, but undoubtedly spending billions, trillions probably of dollars globally on sewage treatment and water treatment with the goal of removing nutrients. So then I have my next poll here, which was to ask how you think eutrophication may affect fish. And I provided a number of different alternatives.
Okay, I'll give everybody a couple more seconds on this one. The panelists can see the votes coming in, so I can see where everybody's at, and I'll share it with you right now.
Great. Well, the answer is, as most of you checked off, all of the above. I asked this question because when I talk to the people about what I do for a living, the general questions that people are concerned about are, can I drink the water? Can I swim in the water? Can I catch fish? And can I eat the fish? And eutrophication is a remarkably complex problem. And depending on degree, the outcomes can be quite variable. As I mentioned, algae are the base of the food web. So moderate increases in phytoplankton and algae can lead to increases in fish production. And in fact, one of the best predictors of fish productivity in a lake is how productive the base of the food web is, the algae. And interestingly, increases in fish growth rates can actually help to decrease concentrations of some contaminants, such as mercury, which is also an interesting outcome. But if algal levels become too high, what happens is after they die, they settle to the bottom into the deep waters, and bacteria decompose their bodies, and those bacteria utilize oxygen in the deep waters, which is essential for fish survival, and that can lead to fish kills. And sometimes these fish kills can be extremely severe, like the picture on the right here, where it eliminates almost all the fish in a lake. So if you get those kinds of conditions, that's very, very bad. Changes in fish habitat associated with eutrophication and algal blooms will also lead to shifts in species composition of the fish community. And typically, fishermen will know that in clearer, less productive waters, that you get things like lake trout. And as you move to more and more productive systems, you tend to get more things like bass and so forth. And in the most eutrophic systems, you'll get things like carp. And I'll also mention that some algae potentially affect the taste of fish. So eutrophication can have a lot of different impacts on fish. So hopefully I've provided a background for you on what is eutrophication, what causes it, and why it's something to be concerned about. And now I wanted to talk a little bit more about some of the research that we're doing on eutrophication at the IISD-Experimental Lakes Area. So ELA is located about halfway between Kenora and Dryden down an old logging road. And it's a research facility that's existed since 1968. For the first 43 years of our existence, or 46 years of our existence, we were a federal government facility. And now we're now run by the International Institute for Sustainable Development, and we are a not-for-profit charitable organization. And our mission is to do ecosystem-based research to better understand the effects of human activities on the environment, and ultimately to try and find science-based solutions to problems that humans may cause. And throughout our history, we've looked at a whole lot of different issues. I'm not going to go into that today, but we have had tremendous impact on government regulations, on best practices, and so forth for dealing with a wide variety of environmental issues. And the reason that we've been able to have that success is there's a multitude of reasons, but there's two really big reasons for it. And the first is that we have a absolutely unique ability to conduct whole ecosystem experiments. And there is nowhere else in the world where you can do whole ecosystem experiments with the ease that you can do them at ELA. And that's because there's special legislation that allows us to conduct these whole ecosystem experiments in 58 lakes and their watersheds at the Experimental Lakes Area. And all these lakes are very, very small. The second reason, and I'm not going to talk a lot about this today, is that we have this very unique long-term data set on freshwater. And this includes lakes at ELA that have both been manipulated and have not been manipulated. And this data set has become really, really important for understanding things like the effects of climate change and so on. So these two things have contributed to making research at ELA some of the most influential anywhere in the world. So ELA was originally created in 1968 to address problems related to eutrophication. And the primary goal at that time were concerns about the Laurentian Great Lakes. And at the time, the main question that limnologists, that is scientists who study freshwater, were concerned about was which nutrients were most important for causing cultural algal blooms. And as I mentioned, algae need all sorts of different elements to build their bodies, but the focus then and still to this day was primarily on carbon, nitrogen, and phosphorus. And some of the elements that algae need are readily available as compared to what they need to build their bodies, and other nutrients are less available or they don't need them that much. So the concern was trying to identify which nutrients were what we call the limiting nutrient, that if the algae don't get this nutrient, then they can't grow. And that is the element that's available, is least available relative to the needs of the algae. In the 60s, and I'm actually sorry to say even today, that one of the main ways that people try to determine what is the quote unquote limiting nutrient for an algal community is to use things like this algal bioassay that I've got a picture of here on this slide. And essentially what you do is you go to a lake, you collect water with the algae that's in it, and you inject different nutrients into these flasks and see which ones cause the most growth. And based on small scale studies like these, in the 1960s, many scientists concluded that carbon was most likely to be the nutrient responsible for causing this algal growth. And this was picked up on by detergent companies as an excuse not to reduce phosphorus in their detergents. And phosphorus is a very major component of a lot of detergents, especially back at that time. Oh, and what I should say is that it's essential to understand what these limiting nutrients are, because this is what will guide you on how to manage eutrophication. If you know what the limiting nutrients are, that's what you're going to target when it comes to sewage treatment, when it comes to land management practices, so on and so forth. So you need to know what nutrients are causing algal growth so that you can come up with strategies to manage eutrophication. So back in the 60s, and this is before I worked at ELA, there was a series of experiments that were undertaken to look at the potential role of different nutrients in promoting eutrophication at the ecosystem scale, at the scale of the whole lake. And I've got pictures of two of these experiments here. On your right and upper left are pictures of Lake 226, and this is a double basin lake. You can see it on the right. It has two basins, and the two basins were separated by a plastic curtain to prevent water movement between them. And carbon, nitrogen, and phosphorus was added to one side, and carbon and nitrogen was added to the other. And you can see that the side that got phosphorus turned bright green with thick blooms of algae, whereas the side with carbon and nitrogen remained clear. The picture in the lower left is the site of our longest running experiment at ELA. We have been now adding nutrients to this lake for 54 years. And I'm going to show you a little data from it later. And we've been adding nitrogen and phosphorus in various combinations over the years. And again, you can see how green this lake is as compared to Lake 305, which is in the background and is typical of lakes in the area. These studies and a number of other studies done at ELA unequivocally showed that phosphorus was critical for causing these algal blooms, and that this is the element you really need to focus on if you want to reduce eutrophication problems. And these results differed from these small scale bottle assays that pointed to carbon. And this is something that we see consistently when we do research at ELA, is that predictions based on small scale studies like those algal bioassays frequently do not predict well what happens at the ecosystem scale. The reason that carbon isn't a problem in these lakes is that there's a vast reservoir in the atmosphere and from sediments and things like that that are not available in flasks but occur in natural lakes, and the algae can access that carbon, and it will not limit their growth. So nobody really talks about carbon anymore following these experiments. So I just wanted to talk briefly about solutions, and I'm going to come back and forth on this throughout the rest of my talk. And this is a slide that I pulled from a paper by Hans Perl and co-authors that shows a number of different ways to reduce eutrophication problems in lakes. And really, the only long-term effective way to reduce eutrophication in lakes is to reduce nutrient inputs, and that's this upper left corner. There have been a whole lot of other methods, various technological approaches that have been developed, such as chemical treatments like Phoslock or alum to remove phosphorus from the water column. There are mixing methods. You'll often see things like fountains in golf course ponds and stuff like that. Sediment capping or sediment dredging and so forth. All of these methods, these technological methods, are effective only short term, and they're all very expensive. And none of them can be utilized in large systems. So for something like Lake of the Woods, none of these methods are really going to be effective at reducing algal problems. And really, at the end of the day, you need to focus on reducing the amount of nitrogen phosphorus that's added to lakes if you want to resolve eutrophication problems. And you can see this from some of the work that we've done at ELA. Whoops. There. I'm trying to avoid using too many graphs in my talk, but this is just a picture showing changes in phytoplankton biomass in Lake 2 to 6. That was the double basin lake that I showed you earlier. And you can see during the period when we were adding phosphorus in gray, algal biomass increased a lot. And then when we stopped adding phosphorus in 1979, I think, the lake rapidly recovered and algal densities returned to their natural levels. Okay, so I wanted to talk a bit about some of the more recent work we're doing. And well, I've talked, while the early work at ELA definitely showed the importance of phosphorus, there's still been a lot of questions around the role of nitrogen. And a lot of the questions being asked is it necessary to reduce loadings of phosphorus alone? Or do you have to reduce both nitrogen and phosphorus together to remediate culturally eutrophied lakes? And I will say this is a very controversial issue, and I don't have time to discuss all of the details of it today, but I'm going to provide a couple of examples from work we're doing at ELA. And I will say that many jurisdictions in the US and Canada have concluded that have put in place regulations that require the removal of both nitrogen and phosphorus together. So, and most of these jurisdictions have cited the precautionary principle as the reason why you want to do this. That everybody agrees phosphorus is important. There's uncertainty about nitrogen, but given that we don't know for sure, we should probably remove both. That's the way they would phrase it, I think. But I'll tell you why I think this is important for us to consider further. First, we're spending billions, probably more, much more of dollars on controlling eutrophication. And dual nutrient management approaches are far more expensive than phosphorus only approaches. And dual management, the removal of nitrogen, is much more expensive than phosphorus only management. And these high costs, I think, discourage action, and they have deflected resources away from phosphorus only approaches that may be just as effective, and those resources could be used in other ways, other important ways. And a good example, I think, is provided by the city of Winnipeg, where the province has mandated both nitrogen and phosphorus removal. The city of Winnipeg is now facing a $1.8 billion cost for upgrades to the North End sewage treatment plant, and that is a lot of money for a city the size of Winnipeg. And for I think this reason, I can't say for sure, the city has continued to kick the ball down the field to has avoided these upgrades to the sewage treatment plant, and high levels of phosphorus and nutrients still flow from the plant and contribute to problems in Lake Winnipeg. And I feel that this focus on nitrogen has led us to not take action on phosphorus, which can be done much more inexpensively. And I'll show you just a little bit of data from ELA. I don't know if everybody, I have the top of my slide is being covered. I'm not sure if everybody has that problem or not. I'm not sure how to get rid of that. Anyway, hopefully not. Anyway, these are two graphs showing data from Lake 2 to 7. This is that long-term eutrophication experiment that I showed you earlier. And we have been adding nutrients to this lake now for 54 years. The top panel shows changes in total phytoplankton biomass in this lake over time. The little red line that you may or may not be able to see on the bottom is average densities for other lakes at ELA. So you can see how high the phytoplankton is in 2 to 7 compared to other lakes in the region. And throughout the 54-year history of this experiment, we have always added the same amount of excess phosphorus, but we have altered the amount of nitrogen that we have added to this system over time. Initially, we had relatively high nitrogen, then we reduced nitrogen, and ultimately in 1990, we stopped adding extra nitrogen entirely. So the only nitrogen this lake receives is from natural sources. And if you look over time, there has been no decrease in phytoplankton biomass in this lake associated with the changes in nitrogen. And on the bottom, I've just shown changes in a particularly important group of algae in this lake that have greatly increased following the nitrogen reduction. So there's no doubt that the reductions of nitrogen greatly affected the species composition of algae in the lake. And in fact, we've seen more blue-green algae, which are usually considered undesirable, since we reduced nitrogen than before. But algal biomass overall has remained unaffected. And so our conclusion from this is that we need to focus our efforts on reductions of phosphorus. And this is analogous to nitrogen control in a high phosphorus situation, and the nitrogen control has not had any influence. And we've done a lot more research on this problem that I don't have time to go into today. We have added phosphorus alone to a couple of lakes recently at ELA, and these have stimulated algal blooms and blue-green algae. So the research at ELA strongly supports the conclusion that phosphorus should be the focus of our attention. And there's evidence from other lakes. Following the research done at ELA and many other places in the 1960s and 70s, there was a lot of effort in the Great Lakes put into reducing especially point sources of nutrients to lakes. And you can see for this graph for Lake Ontario that there were significant declines of algae measured as chlorophyll here in Lake Ontario with these reductions in phosphorus. And there are many examples around the world where decreases of phosphorus have led to successful management of eutrophication and decreases in algal blooms. There are no examples where we have reduced nitrogen alone and seen any effects on algae. Now in Lake Erie, many of you may be aware that after some initial successes, we have seen increases in phytoplankton once again in this lake. And this appears to be related to increases of diffuse inputs to the lake from things like agriculture and from sediment recycling. So the successes were greatest when focused on these point source inputs. So I wanted to finish my talk today talking about Lake of the Woods. Unfortunately, Lake of the Woods does suffer from algal problems. And the most recent State of the Lake report indicated that the lake was impaired with respect to nutrients and eutrophication. And you can see in the satellite picture, which I took off of the Lake of the Woods Water Sustainability Foundation website, shows some very intense algal blooms, mostly around the southern areas of the lake. And one of the things about Lake of the Woods that most of all of you will, I'm sure, be aware of, it's a very, very complicated lake. It has lots of little bays and inflows and separate areas. And so the prevalence of bloom problems in Lake of the Woods varies considerably around this complex basin. And because the lake is so complex, it's hard to fully understand the impact of activities in the different parts. And even in, while the whole activities in some of these isolated bays may not affect the lake as a whole, they may have considerable influence in those areas themselves. And while there are reports of algal blooms in Lake of the Woods that date back, I think, as much as 100 years or more, the size and intensity of blooms appears to have increased in recent decades. Oh, so I had a poll. So I wanted to ask people how they felt phosphorus concentrations in Lake of the Woods compared with other eutrophic lakes like Lake Erie and Lake Winnipeg.
Okay, I'll give a 5-second warning here.
Okay. Let's minimize this. So there we go. I pulled this graph from the State of the Lake report that was done in 2014, and it just shows phosphorus concentrations in various locations around the lake, and they're more or less ordered from the north to the south end. And hopefully you all can read this. Generally, it's considered to be a problem when phosphorus levels exceed 30 to 35 micrograms per liter, and you can see that certainly in the south end of the lake. This is seen quite a bit. And the levels of phosphorus in Lake of the Woods are at times and places equal to and similar to Lake Erie, Lake Winnipeg, or even Lake 227, that lake that I showed you earlier that we're working on at ELA. So there's no question that Lake of the Woods has at times quite severe phosphorus levels, or high phosphorus levels. And in a lake the size of Lake of the Woods, as I mentioned, really the only real solution to eutrophication is reduce nutrient inputs. And then to effectively manage nutrient inputs, you first have to identify what the sources are and what are the hotspots. And Lake of the Woods has a large, complicated watershed with many different geologies and different land uses. So the southern area tends to be more agricultural, the northern area tends to be more Canadian shield and forested. And the management of Lake of the Woods is very complicated because it's a multi-jurisdictional watershed. It's shared by 2 different countries, by multiple states, provincial, federal governments, and this makes it very hard to manage the eutrophication problem in this lake. Recently, thanks to the efforts a lot thanks to the efforts of the Lake of the Woods Water Stewardship Foundation. The lake has got an International Joint Commission designation, which has, I think, helped to focus attention on the lake, but there's still a lot of work that needs to be done. And I pulled these two graphs from an Environment Canada information sheet. I just had a couple of points that I wanted to make. The graph on the left, the pie chart, shows sources of phosphorus to the tributaries of Lake of the Woods. And the main point I wanted to make is that the bulk of the inputs come from forests and wetlands, and human sources are a relatively small component. And as a result, it's going to make it hard to reduce phosphorus inputs to Lake of the Woods, in part because there's not a lot of room to work with here. And when you look at the total sources of phosphorus to Lake of the Woods, that includes the tributaries, but also other sources, it's important to note that there's a large amount of nutrients that appear to come from nutrient recycling, that this is from old phosphorus that was added to the lake and keeps coming back over and over and over again. And an interesting thing about Lake of the Woods is that when people have looked at changes of inputs of phosphorus into the lake, they have actually been coming down, but there hasn't been a decline in algal populations to follow those changes in inputs of phosphorus. And it appears to be because of this relatively high internal loading of phosphorus. In the end, that phosphorus comes from old phosphorus added to the lake, and it will come down as we decrease phosphorus inputs to Lake of the Woods. It just slows that, the effectiveness of those decreases. And so we have to stay the course on Lake of the Woods. And in a sense, we're paying for the sins of the past because this phosphorus is coming back to haunt us now. And until that phosphorus ultimately becomes buried by lower phosphorus sediments, it will continue to be a problem. But that seems to be one of the reasons why the lake is responding rather slowly to changes in phosphorus inputs. And finally, there is evidence from things like sediment cores and long-term reconstructions of algal blooms in the lake that climate change may be making the situation worse too. This has been an intense area of research, but what are the effects of climate change on eutrophication? And the general conclusion is that climate change is likely to make eutrophication problems worse. And undesirable blue-green algae tend to proliferate in warmer waters, and changes in precipitation will greatly affect the delivery of phosphorus to lakes, and changes of ice cover and so forth are also very important. So there's no question that climate change is going to affect eutrophication. And as the last slide I had was just to talk about, so what can you do? If you're using a septic system, please make sure it's maintained well and designed properly. And the Lake Smart team are there to help you. They can give you information to help out on this. There's still many detergents and soaps that have high levels of phosphates, and I would urge you not to use those if you can. Again, fertilizers, people put fertilizer on their lawns to help them to grow. And because lawns are plants and algae are plants, if you put too much fertilizer on your lawn, it will get into the water and this will cause eutrophication problems. And similarly, while we need fertilizer for agriculture, it's very important to match the demands of the crops with the amount of fertilizers added so that excess nutrients don't flow into the lakes and rivers. Wetlands and buffer strips of vegetation along shorelines are very effective ways of intercepting nutrients as they flow across the land and potentially into water. So wetlands and buffer strips are really important to maintain along shorelines to help reduce eutrophication problems. And lastly, I'm going to make 3 requests for donations. One would be to Lake of the Woods Water Sustainability Foundation. I have watched the work of this organization for many years, and I have to say they have been really, really effective at moving the ball down the field with respect to dealing with water quality issues on Lake of the Woods. And I mentioned the IJC designation, but they've been really very effective at advocating for Lake of the Woods and bringing about change. And also the Lake of the Woods LOWDSA and the Lake Smart team. And finally, thanks for listening. My last plea is that if you're thinking about making donations, I would really ask you to consider us, the IISD-Experimental Lakes Area. We can only do the research that we're doing on eutrophication and many, many other water quality issues with support from people like you. Thanks.
Awesome. Thank you so much, Mike. That was great. I feel like I learned a lot. Can you hear me? Okay.
Yes.
Okay, perfect. I feel like I learned a ton, and I'm sure everyone else did too. And it's kind of nice. A lot of our audience had some background, so it's just, you know, reiterating all the important pieces on eutrophication. So I love that. We do have some questions here, if you are ready for them. The first one is about ELA's like whole ecosystem experiments, and he's wondering if there are any that are including carbon and phosphorus in the experimental lakes instead of just, you know, nitrogen and phosphorus and just phosphorus.
Yeah, well, there's been fewer carbon studies recently, because I think it's pretty widely agreed that carbon is not the cause of eutrophication. But when it comes to nitrogen and phosphorus, there's been every combination added to different lakes at ELA and different loading rates as well. And the conclusion of those studies is that phosphorus is the element you need to be most concerned about.
Awesome, thank you. The next one here is there a reason why the amount of blue-green algae would increase with the decreased addition of nitrogen to the ELA lake?
Yes, because there are certain kinds of blue-green algae that are what they're called nitrogen fixers. So they have special organelles that allow them to use dissolved nitrogen that comes from the atmosphere. Most algae require different forms of nitrogen, nitrates or ammonia, but these algae can utilize nitrogen from the atmosphere. And so those blue-green algae actually do better under conditions of low nitrogen. And they have an advantage over other forms of algae that can't use atmospheric nitrogen.
Cool, thanks for that. I actually didn't know that, so great. The next one here is, what is the biggest concern when it comes to increasing algal blooms? So I'm thinking this is more of like a residential concern.
I mean, it depends on the use on the person, I guess. There's no question that the sort of in the most extreme cases, concerns about toxic algae and fish kills are probably what are the greatest worry. But having said that, extremely toxic algal blooms are very rare. So I would say that the majority of people are probably concerned about the degradation of the recreational value of water. Although tastes in water, or I often get comments even in Winnipeg about the taste of the water, which can be caused by algal blooms in water supply. It depends.
Okay. Let's see here. There's quite a few questions coming in. Has ELA considered conducting a study assessing the effectiveness of reducing both phosphorus and nitrogen together as opposed to a single nutrient N or P alone?
Yes, well, the early studies at ELA did reduce carbon or nitrogen and phosphorus together. That slide I showed you of Lake 2 to 6 with the recovery of the lake, that was actually a reduction of both nitrogen and phosphorus in that system. And then the 2 to 7, which was the long-term study with different levels of nitrogen, we kept the phosphorus high but reduced nitrogen selectively. And in that case, it didn't work effectively. And there have been other studies at ELA where we've reduced nitrogen and phosphorus. We reduced phosphorus, it decreased the algae a lot, and then we added nitrogen, and it didn't. Anyway, in all the different combinations, it's always the phosphorus that is the driver.
Awesome. We have Christine Condi, I hope I'm saying that right, from 3 Mile Lake Association in Muskoka, and she's wondering, so the APP Cyano Lakes data seems to compare with what we're seeing here in real time. Are we able to comment generally on the satellite biomass imaging as a tool for lake associations?
Oh, yeah, I'm not an expert on the use of satellite technology, although it is growing rapidly. And I will say also that for Lake of the Woods, there is, for those of you that are interested, a bloom tracker that you can go to online that shows the latest satellite images from the lake and where blooms are occurring. I think they're a very useful tool. There are some issues in lakes like Lake of the Woods. I was talking with Todd Sellers yesterday, a couple of days ago, who's the head of the Lake of the Woods Water Sustainability Foundation. And he was remarking that things like a lot of wind can mix down algae. They only see the surface, the satellite photos. So that can cause sort of false impressions on occasion. But regardless, the widespread coverage of the satellite photos is incredible. The only other alternative is to go to lakes and sample them. And of course, that's very time consuming, expensive, and so forth. So it's really a very powerful tool indeed, and very useful.
Awesome. So we have another question here, which is there any way for lake users to tell a difference between a harmful and a non-harmful algal bloom?
No. I don't think so. I think generally you're going to have to rely on the experts to tell you what the taxa are in the lake and to do the analyses of toxin levels and things like that.
Okay. And how many more questions do you think you can handle here? We've got.
I'm fine with whatever.
So should septic systems permits have an expiration date? So communities on water systems ban the sale of phosphorus containing products and home use herbicides. Oh, sorry, should communities on water systems ban the sale of these products? I'm a bit sorry. Okay, so I guess what he's wondering is for aged septic systems, for example, on the Lake of the Woods, there are tons of systems that have been put in for years and maybe have low maintenance or haven't been checked on in a while. Do you think they should implement an expiration date on these?
I'm not an expert on septic tanks. I sort of deal with the lakes after the nutrients get into them. So I don't feel comfortable saying yes or no. At the end of the day, it is essential that we check and see whether our sewage fields are working and effective. I'm hoping maybe those of you with the Lake Smart program may be able to help throw the ball back in your court. I know in Manitoba, we have a cottage at Falcon Lake. They've actually mandated that septic fields are no longer allowed. It's only septic tanks. Maybe there may be someone else on the webinar that can give a better answer than I can.
Sure. And then I have raised hand here. I'm gonna unmute you there, Todd, and see if you can
be able to.
I think I'm unmuted, am I?
You are.
Good, thanks. And thanks, Mike, and thanks for the shout out. Really appreciate that. It's Todd Sellers from the Lake Woods Water Sustainability Foundation. The septic issue is, it's complex. And Mike's right. We need to make sure we do what each of us individually can to make sure that our own systems are up to snuff and appropriately maintained. On the greater scale of Lake of the Woods, it's massive 4,000 kilometer extent. It's a very small percentage of the total phosphorus budget. And we know that from the phosphorus budget that we did almost 10 years ago. But in the isolated areas, in the individual bays, let's say Poplar Bay, Clearwater Bay, or downtown Kenora, it can be upwards, if they're all leaking, of 30-35% of the phosphorus entering the lake. So just because it doesn't seem like a big problem across a 4,000 square kilometer lake doesn't mean it's not important. It is. And just a small p political comment. In Ontario, I think there's a hole in the septic regulations. It was codified in the building code 20 or so years ago. And in an area that has large areas of unincorporated, or what some people call unorganized territories, where there's no, let's say outside the city of Kenora or Sioux Narrows, where there's no municipality to administer the building code, the Northwestern Health Unit is stuck with small scale, septic. And they don't have the resources to monitor, to recheck aging systems. So I think it's up to individual lake associations to kind of take the lead on this. And Ingolf was one lake a number of years ago that went to the health unit and said, we want you to come in and re-inspect, and we'll help support you doing that. But without that kind of grassroots self-ownership, there just isn't the infrastructure in Ontario. The only time your septic needs to be re-inspected or brought up to snuff is when you do a severance. You carve off a lot. Then the existing property has to be brought up to code. But there's no requirement on title transfer when you sell or buy a lot. And this is, I think, it's a policy vacuum that maybe all of us in lake associations and who care about the lake should maybe start thinking about, making a mission through, including through FOCA, the Federation of Ontario Cotters Association, maybe taking that to Toronto, that maybe this is something that could be a first step, is at the very least on title transfer, require a valid permit. Anyway, that's my soapbox for the day.
Thanks, Todd.
Thank you.
Yeah, I know a big part of our job when we do doc visits is chatting with people about their system, asking them what they know about it, when it's been updated and checked. But we are a small team, and so I would have to say that you're probably right there, which might be a little bit controversial. Okay, here we go. We have a couple more questions, and we're going to start here with some who defend the control of nitrogen express a concern about state change if nitrogen is not controlled. What is the state change that is of concern, and has it occurred in other Great Lakes?
Not sure exactly which. I mean, the whole issue of state changes is talked about a lot in ecology, but I'm not sure specifically which state change they would be talking about. I will say, so as a limnologist, there are certain situations that I think may be worthy of consideration of nitrogen control. One, it's important to recognize that high nitrate levels can be a problem in groundwaters sometimes, but in surface waters, it's not virtually ever an issue. Many marine ecologists believe that nitrogen is important in estuaries and the ocean. But I will point out that that conclusion is derived using the same sorts of small scale studies in flasks and so forth that have been done in lakes. And many people do not believe that nitrogen is important in the ocean, but I will defer to the marine ecologists in that case. But I still think this is where, some thought about where you are. For example, Winnipeg, there's a long way between Winnipeg, the city of Winnipeg, for example, and the time waters enter the ocean, and a lot of processing of nitrogen that would happen in between. So I do not, I think the context is important in that case. And the last place is there has been some discussion about what is the role of nitrogen in toxin production, because some of the algal toxins actually have a fair amount of nitrogen in the toxins themselves. But generally, these toxic algae only occur in eutrophic conditions. And I feel if you reduce the phosphorus, then the toxic algae will follow. And that really it should be about removing the phosphorus.
Awesome, thank you. And then we have from an anonymous attendee that you indicated climate change will play a role in the future, but how much of a role do you think it will play in increased algal growth right now?
Well, that's an interesting question. I don't know that we have the answer, but if you look at the experimental lakes area, we have seen an increase in temperatures, especially in the shoulder seasons over the 54 years that we've maintained our data sets. And there, as I said, there have been a number of long-term reconstructions of algal changes in algae in Lake of the Woods using sediment cores and the remains of algae that are preserved in the mud. And the conclusion of several of those studies is that current conditions have been influenced by recent changes in climate change. So it may well be that recent changes in climate have contributed to some of the problems in Lake of the Woods.
Okay, I think we've got time for one more here, which is, do you know if there is any progress in reducing the Rainy River input of phosphorus? So I guess more of a water management plan that's focusing on the reduction of eutrophication.
Yeah, well, yes, over the long term, there have been reductions in phosphorus from the Rainy River, and this is through things like management of inputs from pulp and paper mills and so forth. And recently, the state of Minnesota has come up with a phosphorus management plan. Is very specific. So at least for that side of the Rainy River, there is a plan in place. There is not one yet on the Ontario side. Not sure if that answers the question. But
Yeah, I think so. Awesome. Well, I think that might be, we're already a little over time here. So I think that might be all the questions we have time for, but I want to say thank you so much, Mike. That was great. And thanks for your expertise in answering the questions that we've had here at the end. We had a very large audience, which I'm very excited to say is our biggest one yet for webinars. So thank you for that. And we also have to say a quick thank you to all of our sponsors at LakeSmart who helped make our online and in-person programs a success. So I think with that, we'll probably end the webinar for today. And yeah, thank you to everyone for coming.
And I'll just quickly add, I should have included my email address, but if people have questions and they want to email me directly, it's mpatterson with 1 T at IISD-ELA.org. I'd be happy to answer any questions that we didn't get to.
Perfect. Thank you so much, Mike.
It's my pleasure.
That was great. We have tons of guests here in the chat thanking you as well. So
Well, thanks for inviting me.
perfect.
Hey, thanks everybody.